Welcome to the first FRC Java series of tutorial lessons. This is going to be Java for programming robots. Before we start with programming robots, though, we need to know some fundamentals about how Java works. We're using the Eclipse IDE, and there's another video lesson that should walk you through how to download and install the Eclipse IDE. So at this point, everybody should have a workspace open and the Project Explorer visible. In the Eclipse IDE, when you want to start a new Java project, you can right-click in the Package Explorer, then select Java Project, and then you have to give your project a name. My recommendation is always give your project a name that ends in the word project, so we'll call this Intro 1 Project. Click the Finish button to actually create the project. In the Package Explorer, you'll now have a project folder. Click the disclosure arrow to open that folder, and inside that folder you will see a subfolder called SRC, which stands for source. This is where your Java source code gets stored. So we want to create a file in the SRC folder, so we will right-click on SRC and do new, and everything in Java is stored, or most things in Java are stored in class files. We're going to create a Java class, and then we're going to give it a name. And the first step in running a Java program is to have a class that has a main method. So we're going to call this our first project runner. A runner is simply a project that has a runnable set of code in it. We're going to click public static void main to have it create a stub for us that has a main method, and then click finish. Now at this point, we want to get in the habit of quickly creating a JavaDoc that describes what this project is. To do that, in front of your public class and then your class name, you're going to hit / and 2 asterisks. And when you hit enter, it will fill in for you a JavaDoc comment. A JavaDoc comment is something that other programmers can easily view that will tell them about your program. So you just put in a brief description of what this class is. So I wrote this class as part of the first FRC Java tutorial lesson, and then put your name in. You can also add additional comments using tags. These tags are designed to help you keep your code clear. The one tag that I would always recommend you add in addition to your name is the version tag, and the easiest thing is simply to make the version a last modified date. You can come up with version numbers, but dates work very well, and they're easy to maintain, and there's very little confusion about date order. OK, next, what we want to do is add a JavaDoc comment for our actual main method. And what is a main method? A main method is the method that Java will run when I start the first project runner class. If a class does not have a main method, then it cannot be run in Java. So we now want to add our JavaDoc comment using the same system, a / and 2 asterisks. Hit enter, and then we're going to write a description of what this does. This will start my code for this lesson. And then it also fills in this param tag. A parameter is the thing after the method name that is inside the parentheses. In this case, the parameter is a string array. And you may not know what a string is or what an array is at this stage, but the names really are what you have to learn first. It is a string that is a Java type, and if I hover over it, notice that I get a JavaDoc comment about strings. One of the nice things about the Eclipse IDE is you can gain all kinds of information built in within the system. So if you don't know what a string is, there it is for you. Read about it, and you're ready to move on. The double brackets means that it is an array. An array is a list of values. And then after the type, and this is the type of this parameter is string array, comes the parameter name. In this case, it's args, which stands for arguments. This allows us to call this method with values already filled in. Under normal operating conditions, you won't do this, so we can ignore it for right now. And then Eclipse fills in a method stub, and notice it says to do, auto-generated method stub. What it's telling you is, hey, you're supposed to put something here. So the simplest thing to do is everybody's first program that they write should be outputting something to the console, and by long programming tradition, it is hello world. Eclipse, however, has many ways that it can save you time. One of them is if you type SYSO and then hit Control and space on the keyboard, it will fill in for you a System.out.println command with the parentheses already in, and then you can enter the string that you want to appear in the console. Hello world. Now, what is System.out.println? System is a collection of methods, code collected together that is part of the system library. And if you look in the system library, there's all kinds of code in here. These are the built-in things that are part of every Java program. Inside the system library is a method called out. And that method, I'm sorry, it's not a method, it is a, what is it? If we hover over it, that's right, it's a public static final print stream. A print stream is an object that allows us to send information somewhere else. And the default is it will send that information to the console. We can redirect that output to other sources. So for example, if our robot had an LED display, we might be able to use the System.out library to redirect output to that LED display. And then within the out static final, we have a method called println. And println allows us to pass a string to it. And then if we run our program, that string gets output to the console. Now, in Eclipse, the first time you run a program, it will ask you if you want to save your code. Be sure to check the Always Save Resources before launching box, and then you never have to click it again. And every time you run your program, your code gets saved first, so when your computer crashes, you don't lose anything. Click OK, and then your code runs. And you see Hello World in the console down here. When you are outputting information to the console, there's a few special characters that you should know about. If you put a \n in, it is an escape sequence. Backslash is the escape character, n is the special character that follows it, and what it will do is print a blank line. So if I put something else after the \n, like blank line, and then run the program again, I'll see Hello World. Oh, that was, I should have, oh, Hello World. Wait. Why didn't it do a blank line? I should have seen a, oh, it did. Hello world, and then blank line is on the next line. If I wanted to skip a line, I would put 2 blank lines in to actually have a gap between those lines. Some other useful escape characters that you need to know about are, if you want to actually put a backslash in your text, 2 backslashes will print a single backslash. A backslash T will do a tab character. And a backslash followed by a quote will allow you to put a string actually in quotes. So, up to this point, we have simply output something to the console. Our next step is going to be to declare a variable. To declare a variable in Java, you first specify the type. Common types include int, which is a primitive type, and you will know it's a primitive type because the first letter is a lowercase letter, and then the variable's name. And then you can assign that variable a value. You do not have to assign it a value, so that is considered an optional step. If I were describing these steps, I would say that I first specify the type, then the name, and then I can optionally assign it a value. This is referred to as declaring a variable. A variable only exists in Java within the enclosing code block that it was created in. And it only exists after it's been declared. The code block is represented by all the area encompassed by the curly braces. So this variable exists within my main method. I can create another method, public static, and this method can return a value. The return type comes before the method name. So I'm going to make a method that calculates any base and power. So I'm going to write int as my return type, and then I'm going to call it power. In order to calculate a power, I need to have 2 variables. I need an integer that represents the base, and I need an integer that represents the exponent. In this case, I have written a method by following these steps. I have written the Java keywords, public and static, which our methods will be for the time being until we get to objects. And then I have included the return type, which is an integer. And then I have included the method name, followed by parentheses with my parameters or parameter inside the parentheses. Each parameter is a declared variable. So it follows the same rules for declaring a variable as I did above. It includes a type and a name. I don't assign it a value because its value will come when I call the method. Now, I've got my method. What I don't have yet is a return value. So I get an error saying the method must return a result of type int. So I'm going to just get rid of that error by having it return 0 always. That will allow me to start writing my method code and any syntax errors that I find along the way can be highlighted and won't be obscured by not returning a value. So, in order to calculate the power of a number, I'm going to have a variable to hold the total. And because I'm dealing with integers, I'm going to make that variable also an integer. I'm going to call my variable total, and I'm going to give it the value of 1. Next, I need to actually start multiplying total times base exponent times. And for that, I can write a loop. And the most basic form of loop in Java is a while loop. I say, while some condition is true, keep repeating this bit of code. So in this case, while exponent is greater than 1, I'm going to keep repeating this loop. Each time I repeat this loop, I'm going to take total, and I'm going to assign it the value of total multiplied times base. So if base was 2 and exponent was 2, I would repeat this loop infinitely unless I do something to change exponent. So I'm going to now decrease exponent by 1 each time this loop executes. And what I'm going to see is that when I'm done, I now want to return total. Only if I've done my math correctly, I will get the correct result. But if we substitute some values and follow our code, so if base were equal to 2 and exponent were equal to 2, what would happen? Well, down here, total would be 1. Then at this point, I would take total and I would make it equal to 1 times 2. So it would now be equal to 2. And on the next line, exponent would be equal to 2 minus 1. So exponent is now equal to 1. And then I'm going to repeat my loop. Up here, I'm going to compare exponent, which has a value of 1, with the value of 1 and ask, is it greater than 1? And the answer is no, exponent is not greater than 1. So my loop will end, and I'll return with the total 2, which is an incorrect value. My exponent needs to repeat as long as its value is greater than 0. This will cause the loop to repeat one more time and should give me a correct answer. And now I can try actually executing my method and see if I get the correct result. So I'm going to say I want to do a System.out where I want to print varname to the power of varname equals, and then I want to substitute the results of calling my method with varname for both values. Now, to make this easier to check the answer, let's reduce varname to 2 and see if we get the correct result. Is 2 to the second power 4? And the answer, hopefully, is yes. Now let's change it to 3. Is 3 to the third power 27? And hopefully we can see that the answer is yes. If I want to get a slightly higher value, I can see that 4 to the fourth power is 256. However, let's put our code back so that the code was actually wrong, the original version. And then reduce var name to a more manageable number. So now I'm getting the result 3 to the third power is 9. And this will happen quite often. You'll write code and you won't get the result you expect. So the question becomes, how do you identify the problem? And what we're going to want to do is start debugging our code. I can debug my code by putting a breakpoint on a line where I want to stop by double-clicking in the bar to the left of the line where I'd like my code to stop. It will put a small blue dot on that line. And then next to the Run button, I have a Debug button. If I click the Debug button for the first time, it will ask me if I want to switch perspectives. Check the Remember My Decision box so you don't have to do this every time, and then say yes. And now you are in this complex debug view. We're going to shrink up the column on the left because we're not so concerned with our stack right now, but this is our stack. My Java application is running. It called the first project runner, and then it started the main thread. And that main thread is stopped at breakpoint at line 23 in first project runner. And notice that line is highlighted. If I want to see where I am in the main method, I can click on the thread below it, and it will show me that I'm stopped on the line that says System.out, and it stopped when I called the power method. So now I want to go back and see where it stopped, and I can see that the green bar shows that it stopped on the line where it says int total equals 1. And now I can see what variables already exist. My base has the value 3. My exponent has the value 3. Then I can use these arrow buttons to step through my code. Stepping into will actually take you into a method that you have run. Step over will take you to the next line without following into methods that you called in a line. So we're going to step over, and when we do, we see that total gets the value 1. And if I step to the next line, I'm going to see that total gets multiplied times base. So total now has the value 3. And when I do the next line, it jumps back up to my while loop. And I can see that my exponent now has the value 2. Stepping again, I'll see what happens. Total gets multiplied by 3, and so it's now 9. And I know that I should be looping one more time so I get 27. But if I look at this line, I can see that exponent has the value 1. And if I'm not able to follow this expression, I can check to see, is this true or false? By copying this expression and then going to my window menu, show view, and show expressions. And I can add a new expression here and paste that in. Is exp greater than 1? And the answer is false. And because it's false, this while loop will not execute one more time. So I can step, and I can see that that's exactly what happened. And then if I step again, I'll return, and now I'm back at my System.out line. And now I can step through that line and see what my results were. Oops, I stepped into. And so I stepped into the string builder method. If you do that, you use the step return button to get out. What I wanted to do was step over, so I don't actually go into the string builder method. And then I see 3 raised to the 3 power equals 9. So now I want to go back to my Java perspective by clicking the Java button, close that thread window, and now see if I've realized what my problem is, that this should be greater than 0, and then run my code again. And now I have a correctly running method. However, while loops are the most basic form of loop. when you know how many times you're going to be executing a loop in advance, most programmers prefer to write their loops as a for loop. A for loop takes the several steps of a while loop and makes it into one series of steps. And it looks like this. First, the keyword for, and then my expression. In my expression, first I can declare an iterator variable. In this case, it's going to be int, and then something that's going to keep track of how many times I want this loop to execute. And I'm going to say I want it to execute I times. I stands for iterator, and I want I to start off with the value 0. Then the next thing I need is under what conditions does my loop repeat? I want to keep repeating while I is less than the value of exponent. And then my last element is, what do I want to do to my iterator variable each time my loop repeats? And I want it to go up by 1. So I'm going to say I equals I plus 1. And then I start my code block for what I want my program to do. In this case, I want total to be equal to total times base. That will replace my while loop. So I can now delete my while loop and delete my comments that I put in for my test values. And then I can run my program and see if it still works correctly. Does 3 to the third power still give me 27? When you are writing code, you're going to want to test your code under all reasonable inputs. So can I take a value and raise it to the first power? What is any number to the first power? And the answer should be 1. Do I get 1 when I put in 1 to the first power? I can also test it by putting in some other values. 9 to the first power. But if I do that, I need to change my string here to show what I'm now inputting. And is 9 to the first power 1? And you can see our program did not generate the expected result. So now we have to start analyzing where we went wrong. So in this code, we're saying that my total starts out at 1, and then, yes? Oh, I'm sorry, 9 to the 0 power should be 1. That's right. So let's try that. Ah, good, it works. Okay? All right, so, yes, my bad, sorry. Better programmer than mathematician. All right, so at this point, if I've tested my method with reasonable values, I might feel secure in saying that this method works. The next step, and this is very important for FRC programmers, is to document my method. I should write a JavaDoc that describes what this method does, so that the other programmers in the FRC this year or next or a decade from now know what the hell I did and why. To start a JavaDoc comment, I do / and 2 asterisks, hit enter, and then first I put a description of what my method does. This method returns a positive, an integer value. Sorry, this method returns base to the exponent power for values greater greater than or equal to 0. Why did I include limits in this description? Do we think this method would work if we put in -3 to the third power? So can my mathematicians tell me, is -3 to the third power 27? It said -27. Okay. Let's try negative power. Oh, that's going to mess things up. At this point, I really should just start using a whole string here. It'll be easier. So we're doing what? We're doing -3 to the -3rd power. Is that correct? So we want to, if we're not going to correct that in our code, then we want to document it in the JavaDoc comment. So returns base to the exponent power for values where exponent is greater than or equal to 0. The other thing that you can do in your JavaDoc is, since exp and base are actually code values, you can put HTML tags around them to help make the JavaDoc easier to read. Okay, and then I have to document what each of my parameters represents. And then finally, in the return, you should document what your expected return value would be. In this case, it's going to be an integer value representing base to the exponent power. This may seem tedious, but it is going to be important for people using your code later on, especially in robotics, because the values that you have are going to vary widely, and the expected results are very important. There's going to be limits on the input ranges and limits on the expected output ranges, and you need to document them and what they are. And JavaDoc makes that very easy. And Eclipse makes it easy to see. OK, so I now have a complete program that hopefully does something useful. The next step is to realize that Java includes libraries that can do things for me. So we've written a power method. There is a math library that includes useful things like pi, absolute, cosines, tangents, and pow. Notice that their version of pow takes double values as parameters and returns a double value. And notice how complete their documentation is. Sorry? That was going to be the next thing on the list. Okay, so the question is, what is a double? An integer value, or an int is a whole number in the range, and I'm going to cheat here because I don't know the actual range, and I'm going to type integer dot max value and then hover over it and copy the actual number. The important element to understand there is that I used the JavaDoc to get information. This value represents what we call a 2's complement number, which essentially means that the entire range of numbers is split in half. The negative range has a last digit that is 1 greater than the upper range because the range includes 0 in the positive half of the number. A double is a floating point number. So if I declare something as a double, it will look like 1.5. If I try to make an int with the value 1.5, I will get an error because, see what Eclipse tells me, type mismatch. Cannot convert from a double to an int. And this brings us to an important function of Java, which is automatic type conversion. There is an order of precedence. An int is smaller than a double in terms of the amount of memory it takes to store. Any integer can become a double because I can take any integer and add 0.0 to the end to turn it into a double. I cannot do the opposite. I can't take an integer and turn it into, a double and turn it into an integer, because in doing so, I would be losing information. The only way to force Java to do that is to declare a variable that you are going to cast as a type, put the type that you want it to become in parentheses, followed by the variable that you want to change. A double can be forced to become an integer, but it will lose anything after the decimal. So 1.5 will become 1, and 1.9 will become 1. This is the process of casting. The opposite process of an integer becoming a double is the process of expansion. The other variable types that can automatically expand are an int can become a string if it's combined with another string. So I can take int and I can add it to a string. The variable value stored in I, which is 1, will be combined with the string, which in this case is I, and if I output that value, I will see 1 followed by an I. It's important to understand that once I make something a string, it is no longer a number. So if I combine 1 and the string 5, I will not get 6. I will get 1, 5. Not the number 15, but the string 1 followed by a 5. I can also make a string combined with a double. A double has a decimal, and since we took our double from I, which is 1, our double actually has the value 1.0. So now S2 will equal 1.0 plus the string 5. In order to combine those, the 1.0 is expanded into a string and then combined to give me the string 1.05. Other types that will expand include a very important type in Java, boolean. Boolean values can be either true or they can be false. If I output a boolean value, Java will actually output the word true or false. This distinguishes it from many other languages. Boolean values in Java are not just the integer values 0 and 1 as they are in many other languages, but are in fact distinct values, true and false. And just like integers and doubles, a Boolean value can be combined with a string and the same process occurs. S3 will equal false plus the string 5. Expansion will occur, and so false will become a string, which will become false 5. Those are the primary types of expansion that you will need to worry about. You will also see other types. There is the type float, which is also a floating point number, and if you hover over it, float f, I think you'll get a, let's say, float f equals 0.0. Do we get a JavaDoc for float? We apparently do not, which is unfortunate. If you stick with the types int, double, boolean, and string, most of your needs should be met in terms of Java types. Next lesson, we can go into the additional types float and char, which stands for character, which gives you a single character as opposed to a whole string. Okay, so now it is time to start talking about objects. And the first object is the string object. I have created several string objects, S, S2, and S3. If I want to, I can call methods on these objects. An object is different than a primitive data type because an object contains both data and methods to operate on the data. So in the case of a string, I have several methods. if I type the string name and then dot, I will get a list of methods that are available to me. One of the first ones that we want to learn about is length. Notice that the JavaDoc for length tells us about this method. And it's important to learn to start reading these JavaDoc comments, because there's more than we need to teach you than we can teach in these lessons. Some information you're going to have to get from JavaDocs. So, what is the return type of the length method? Well, I can see that it returns an int, so it returns an integer value, and it returns the length of this string. The length is equal to the number of Unicode code units in the string. If you're wondering what a Unicode code unit is, look it up online. But the short answer is, if I add a \t to the end of this string, how many characters did I add to that string? \t is a single Unicode character. So I would expect the length to be one, 2, 3, 4, 5, 6, and then 7 for S3. So I'm going to do a System.out and say S3 equals, and then I'm going to print S3 and say, and has a length of, and then add the length at the end. And let's see if my addition was correct. Yes, it has a length of 7. And notice how far over S3, or the and, is, because I put the tab in. So I've got this giant gap, and if you select, you can actually see that the tab is in there. So length returns the length of a string. What if I want to get part of a string? So I want S4 to be equal to the first 3 letters of S3. I can say S4 is equal to S3 dot, and then substring, and there's 2 versions of substring. One that returns the entire rest of the string starting at a given index, and one that returns a string at a starting index to an end index. Java does substring different than most other programming languages. If I want to get the first 3 characters, I start at the 0th character, and I go, my end index is actually 3, which is the 4th character of that string. I didn't declare the type. So how many characters will be in S4? And the answer will actually be 3, because it's going to give me from 0 character 1 and character 2, but not character 3. It does not include the character at the end index. So I should get FAL. And I did. The other form of substring is to start at a given index and return all of the string starting at that index. So if I start at index 0, what will S5 be? And the answer is it will be the entire string. If I change this to 1, I will be getting the characters from ALSE5 and my tab. Another useful string function is the ability to find out where one string starts in another. So I can say, I want to find out if there's any tabs in S5. So I can say, if S5 dot indexOf, and then I indicate what substring I'm looking for. I want to know if that index value is greater than or equal to 0, because that means that that value is somewhere in my string. And then I can do a print and say, there is a tab in this string. Running my program, I find out that S5 does contain a tab, even though I can't see it. If I go back and remove the tab from S3, I no longer see that there is a tab in that string. indexOf returns -1 if the substring is not found. So another way I can write this expression is to say not equal to or equals -1. Except I want not equals to -1. This says there is a tab somewhere in that string. I can also write an else clause to print there is not a tab in this string. And then if I put the tab back in, I should see there is a tab in this string. However, this is very wasteful code. How much of this print line is repeated? The only part that's different is the word not. So we can break this print up into 3 separate prints that end up with our complete print by doing a print, only this time we don't want to go to the next line when we're done. We want to just print there is a, oh no, we want to print there is, not the a. Then here we only want to print if there is not, a tab in that string, which eliminates the need for the else. We also want this not to be a print line. And then all we have to do is finish our print by saying a tab in this string. Notice that the constructed output is the same as what I had before, except I put an extra space in there. What I've done is do a print without a line at the end, then inserted the word not only if there isn't a tab, and then printed the rest of the string. And that should give me the correct output whether there's a tab or not. Oops, we need a space after not, and not before. These are the 2 different versions of print and print line. String objects can be useful, but they are limited and won't likely be used in a robot. Because how often is a robot going to be printing information? You may be printing to a log file, however, so it's important to know how strings work. However, most often, you will be creating objects of your own. What's the important thing to know about objects? Objects include both data and methods. That is the big idea behind objects and where we will pick up on the next lesson.